Good morning students, welcome you all for online classes. Today we will discuss proof of possession. If a public key and its certificate are created using combined generation, then it is possible for an attacker to attempt to register public key for which they do not know the corresponding private key. The public key and certificate are created using combined generation. So attacker will attempt to register public key without knowing corresponding private key. Such an attack on verification key for digital signature scheme might work as follows. The attacker obtains a copy of Alice verification key, and this is public piece of information, so the attacker can easily obtain this, that Alice verification key. The attacker presents Alice verification key to registration authority along with attacker's legitimate credentials. Then the RA verifies the credentials and instructs the associated certificate authority to issue public key certificate in the name of attacker for the presented verification key. The CA issues public key certificate for the verification key to the attacker. So it will dangerous to get attacker to register his public key but without knowing private key. When it was the public key and certificate are created using combined generation. So the problem comes. The attacker now has public key certificate issued in the name for verification key for which they do not know the corresponding signature key. The problem arises if Alice now digitally signs a message with her signature key, since the attacker will be able to persuade relaying parties that this is actually attacker's digital signature on the message. Because the attacker's name is on public key certificate containing a verification key that successfully verifies digital signature on the message, because he has a certificate issued by CA. This attack can be prevented if the CA conducts a simple check. Certificate authority will going to check that public key certificate applicant knows the corresponding private key or not. This type of check is referred to as proof of possession of the corresponding private key. So CA will going to check whether this candidate has his private key or not. If the public key is an encryption key, then one possible proof of possession is as follows. So registration authority encrypts a test message using public key and sends it to the certificate applicant, along with request for the applicant to decrypt the resulting cipher text. If the applicant is genuine, in this case they decrypt the cipher text using private key and return the plain text test message to the registration authority. An applicant who does not know the corresponding private key will not be able to perform decryption to obtain the test message. So the person compulsory he has to know public key as well as private key. Generating certificate authority public key pairs. Public key certificate involve CA digitally signing the owner's public key together with related data. Related data means organization name and passphrase. Okay. This in turn requires CA to possess a public key pair. This raises the question of how assurance of purpose of the CA's verification key will be provided. Solution for this: it is to create public key certificate for CA's public key, but who will sign the public key certificate of the CA? The most common methods of certifying CA's verification key are: use higher level CA. So what do you mean by this higher level CA? If the CA is part of the chain of CAs, then CA may choose to have their public key certified by another CA. So it's called higher level CA. And self-certification. A top level CA has no choice other than self-certification. For example, CAs who certify public keys that are used in web-based commercial applications need to have their public key certificates incorporated into leading web browsers or have them certified by higher level CA who has done this. Okay, let's see this sample certificate of our video website. So to check the certificate is secure or not, so go for this connection, secure connection, then general media permissions and security. So permissions, use default always ask, then auto play sound block, install add-ons block. So these are permissions who can user perform while clicking on this website. And in security purpose, website name vtu.ac.in, the owner. Website does not supply ownership information verified by this company and expires on 19th July 2021. Let's see certificate. Here the SSL certificate for client and server. So common name, that is CN star vtu.ac.in, organization and organizational unit, domain control validated. Okay, and begins on 19th July 2019 to expires on 19th July 2021. So fingerprints SHA-256 and SHA-1 fingerprint, and here serial number and version number 3. Okay, and issuer, validity, subject, domain control validated, positive SSL wildcard, then common name vtu.ac.in. This is certificate authority key identifier, subject key ID, key usage, certificate policies. These all are policies. Okay, so this is regarding about certificate. Key pair change. Revocation of public key certificate. Withdrawing an existing public key is very difficult. This process is referred to as revoking the public key. Revoking a public key essentially means revoking the public key certificate. Backup of the key certificate. Some techniques are there, total 3 techniques. So in blacklisting, this involves maintaining a database that contains serial numbers. Just now we have seen a public key certificate that have been revoked. This type of database is referred to as certificate revocation list or CRL. These CRLs need to be maintained carefully, normally by the CA, who is responsible for issuing certificates with clear indications of how often they are updated. The CRLs need to be digitally signed by CA and made available to relaying parties. That is black listing. Then white listing. This involves maintaining database that contains serial numbers of public key certificate that are valid, and this database can then be queried by relaying party to find out if public key certificate is valid. An example is online certificate status protocol, and third one is rapid expiration. These removes the need of revocation by allocating very short lifetimes to public key certificates. This of course comes at the cost of requiring certificate to be reissued on regular basis. For example, you can see here begins on 19th July 2019 and expires on 19th July 2021. After that, we are going to make another extend the expiry dates. This is serial number. If you have any doubts regarding this, please ask me. Thank you. Good morning students, welcome you all for online classes. Today we will discuss the public key management models. Choosing CA. Currently the most CAs serving open environments or commercial organizations who have made it their business to be trusted to play the role of CA. The importance of their role may demand tighter regulation of their practices. Options for this include licensing. So this approach requires CAs to obtain government license before they can operate. Government thus ultimately provides the assurance CA conforms to minimum standards. Self-regulation. This approach requires CA to form industry group and set their own minimum operational standards through the establishment of best practices. Public key certificate management models. So what are those models? The owner of a public key certificate has by necessity placed some trust in the CA who issued the certificate. This may be because the owner belongs to the same organization as the CA, or because the owner and CA have direct business relationship. So the model is CA pre-certificate model. Certificate authority pre-certification model. It applies when there is no CA involved. So in this case, it's called pre-certification model. Here owner generates a key pair and then either self-signs the public key or does not use public key certificate at all. Owner can easily generate his or her key. Any relaying party obtains the self-signed public key directly from the owner and then sign to digitally signed, then relaying party. For example, the owner could conduct their public key in an email signature or write it on business card. Relaying party then has to make an independent decision as to whether they trust the owner or not. The relaying party thus carries all the risk in this model because he has to trust the owner who has done digital signature. So it is called what? Pre-certification model. The reputation based certificate model. This is second model. It applies when the owner has obtained public key certificate from CA. In previous model, owner only generating a certificate then making digital sign. But here, reputation based certificate model, he obtained public key certificate from certificate authority. But the relaying party has no relationship with CA. These parties, there is no relationship between certificate authority and this party. Even if the relaying party obtains the verification key of the CA, which enables them to verify the public key certificate, because they do not have any relationship with CA itself, they have to verify with owner only. They are left to choose whether to trust the CA has done its job correctly and hence that information in the public key certificate is correct. In worst case, they may not trust the CA at all, in which case they have no reason to trust any information affirmed by CA. The only assurance they might gain is through the reputation of the CA which signed the public key certificate. If the relaying party has some trust in the reputation of the CA, for example, it is a well-known organization or a trust service provider, then a relaying party might be willing to accept information in public key certificate. And another one is closed certification model. This third model, it applies when the relaying party has a relationship with owner's CA. Okay. In previous model, there is no relationship, but in this model, relaying party has the relationship with certificate authority. The closed certification model is the most natural certification model, but is only really applicable to closed environments. Where single CA or oversees the management of all public key certificates. In this model, more issues concerning public key management, such as those relating to the liability and revocation, are more straightforward to solve than for other models. This is because public key certificate owners and relaying parties are all governed by the same certificate management policies and practices. These relaying parties and owner governed by the same certificate management policy, because he has relationship with this certificate and relaying party also has relationship between this CA certificate. Connected certification model. It applies when the relaying party has a relationship with trusted third party, which in turn has a relationship with owner's CA. This is trusted third party, and this trusted third party has the relationship with owner's CA. The trusted third party which the relaying party has a relationship with could be the another CA. We describe it as validation authority because its role is to assist the relaying party to validate the information in the owner's public key certificate. This validation authority may not necessarily be certification authority. This validation may not necessarily be CA joining CA domains. An owner of a public key certificate has by necessity placed some trust in the CA who has issued this certificate. For larger and more open public key infrastructures, it is likely to be the case that owner of a certificate will want users who do not have business relationship with the owner's CA to be able to rely on the owner's certificate, and also want to rely on certificates that were not issued by owner's CA. So somehow we can join different certification domains and allow certificates issued by one CA to be recognized by another CA. So that's why you can call join the certificate authority domains. So there are kinds of joining CA domains. First one is cross certification. The first technique for joining two CA domains is to cross certification, whereby each certification authority certifies the other CA's public key. For example, consider this one is certificate authority 1 and certificate authority 2. CA and C2 each certify the other's public key. So it is called what? Cross certification. By cross certifying relaying party that Bob of CA2 who wishes to trust public key certificate issued to Alice by CA1. Alice public key can trust Bob public key, because both they have shared their public key with different CAs. So this is called what? Cross certification. Bob trusts CA2 because I have a business relationship with CA2, and CA2 trusts CA1 because they have agreed to cross certify one another, and CA1 has vouched for information in Alice's public key certificate, and therefore Bob trusts the information in Alice's public key certificate. So this is what we can call cross certification. Certification hierarchies. It is used to use a certification hierarchy consisting of different levels of CA. A higher level CA, which both CA1 and CA2 trust, can then be used to transfer trust from one CA domain to another CA domain. Root CA and CA1 and CA2. Here clients of CA1 and clients of CA2. Here higher level CA is termed as root of the CA to issue public key certificate for both CA1 and CA2. Relaying party Bob belongs to CA2, who wishes to trust public key certificate issued to Alice by CA1. Here you can write Alice and here you can write Bob. Bob can trust with Alice public key because Alice public key is issued by CA1, and Alice can trust Bob public key because Bob has issued his public key from CA2. So Bob trusts CA2 and CA2 trust the root CA. Root CA has vouched the information in CA's one public key certificate, and CA1 has vouched for information in Alice's public key certificate, and therefore Bob trusts the information in Alice's public key certificate. Certificate chains. The joining of CA domains makes verification of public certificates potentially complex process. In particular, it results in the creation of certificate chains which consist of series of public key certificates which must all be verified in order to have trust in the end of public key certificate. Alice has a relationship with CA1, and which is a low level CA and whose root CA is CA2. Has a relationship with CA1 and which is low level CA whose root is CA2. Bob has a relationship with CA3 which has cross certified with CA2. Now suppose Bob wishes to verify Alice's public key certificate. To do so, he will need to verify certificate chain that consists of the three public key certificates, certificate 1, 2 and 3, containing public key of certificate 1 containing Alice, certificate 2 containing CA's 1 and certificate 3 contains CA2's. Certified by Alice, certified by CA1, Alice certified by CA1, and CA1 is certified by CA2 and CA2 is certified by CA3. So this is called what? Chaining. Bob first verifies Alice's public key certificate, which is signed by CA1. He will going to verify Alice's public key certificate, and Bob needs to verify CA1's public key certificate, which is signed by CA2. Finally, Bob verifies CA2's public key, which is signed by CA3. The certificate chain ends at CA3. Since this is the CA, Bob has a relationship with, and thus we assume he trusts signatures by CA3. And if you have any doubts regarding these concepts, please ask me. Thank you.